Hello, my name is ISHVAN son of SELVAM. My ID number is EC21073. So for today, me and my group members will be presenting about our Lab 4 project presentation, which is about our hydroponics farm. So what is hydroponics? Hydroponics is a method of growing plants without soil. Instead, plants are grown in a nutrient-rich water solution or an inert medium. This allows for precise control over nutrients, resulting in faster growth and higher yields. Hydroponics is popular in commercial agriculture and home gardening due to its efficiency and year-round cultivation capabilities. These are the main inputs that we'll be using in our project. First, we have the pH sensor, which is to detect the pH value of the water. Second, we have the temperature sensor, which is used to detect the temperature of the water. And thirdly, we have the IR sensor, which is to detect the water level of the water in the container. Next, we have the output. So in our project, we'll be having two outputs, which is two water pumps and LCD display. So the two water pumps will be placed in two different locations. One is to deliver the nutrient water, and the second water pump is to regulate the water temperature. The second image is our LCD displaying the temperature and the pH value of the water. The third image, as you can see, is the LCD, which is fixed on the cover. Next, we have the Proteus schematic diagram that we created. That's all for me.
A very good day, and my name is SOORIYAR unlike RAVINDRAN, and my metric ID is EC21068. Now, I'm going to present about the coding part for our Lab 4 project, which is for hydroponics. We use Arduino IDE to code this project. We use 5 main libraries in this project, which is wire.h, liquid crystal I2C.h, one wire, and Dallas temperature and software serial. Wire, one wire, and Dallas temperature library is used for the temperature sensor. Meanwhile, the liquid crystal I2C is used for the I2C LCD, and software serial is so that we could display the data in the serial monitor. Now, let's show which pins are connected to the Arduino. We have 3 main sensors in our project. First is pH sensor, then temperature sensor, and ultrasonic sensor. The pH sensor is connected to analog O pin in Arduino Uno, and then the temperature sensor is connected to pin 2 of the Arduino Uno, and finally the trig pin and echo pin of the ultrasonic sensor is connected to pin 6 and 7 respectively. And also the pump is connected to the relay, and the relay is connected to pin 8. Relay 1 is connected to pin 8, and relay 2 is connected to pin 9. This will activate the relay, in which the relay will activate the pump later. So let's look at the code for the ultrasonic sensor. So this line of code is the code for ultrasonic sensor. First, we have to trigger the ultrasonic sensor, which will activate the ultrasonic sensor. Then we can measure the duration of the echo pulse that the ultrasonic sensor emits using this line of code, and then we can calculate the distance in centimeter using this formula, and finally we can obtain the distance. Next, for the pH value. From the pH sensor, we have to get 10 samples from the sensor, which will then be sorted from small value to the large value, and the 6 middle part will be taken and the average value will be obtained, and from which the average value will be in millivolt first, and then the millivolt value will be converted into pH value with this formula shown here. And for the temperature sensor, it's this is the line of code for temperature sensors. First, we have to use, for temperature sensor, it's just simple one line code. We just have to use this line of code to obtain the temperature reading from the DS18B20 temperature sensor. And now all of the sensors will be displayed in the LCD, and for that we have to use this line of code. The temperature will be just shown T, and after that this will get the enable the temperature value will be shown on the LCD, and this line of code will enable the pH value that we obtain from the pH sensor to be shown on the LCD. And the code over here is the if-else statement for activating the pump. If the pH value is more than 8, which indicates it's alkaline, it means that the water or solution is not suitable for the plant's growth. It will start the pump, which will input the liquefied fertilizer and nutrients, which is acidic in nature, so that it will increase the pH value, so that it will be a suitable pH for the plant's growth. And the temperature, if it's more than 35, the water pump 2 will be activated, which will vibrate the water to reduce the temperature. That's all the main function for this code, and that's all from me. The rest will be continued by my teammates. Thank you very much.
Assalamualaikum. My name is Muhammad TAQIUDDIN, network number EC21116. Today I'll be talking about simulation and practice of our hydroponic system. So to obtain all of these components, you must first go to P and type in any component you want. After typing all the components that you want, press OK, then exit this. All of the components you want will be on the left here. Press the component, then insert it into the simulation. So after inserting the simulation, connect all of the wires. So as you can see, this is our pH sensor. pH sensor is connected to the pin A0. So after connecting to the pin A0, this is connected to the potentiometer, power, ground, inductor, capacitor and voltmeter. So this is our ultrasonic sensor connected to the potentiometer. Ultrasonic sensor with the echo connected to pin 6 and the trigger connected to pin 7. So you can see this is the temperature sensor, DS18B20 temperature sensor connected to a resistor, ground and connected to pin 2. So this is our virtual terminal. The RXD and TXD are connected to the RXD and TXD, and these are the 3 LEDs, yellow, green and red, all connected to pins 3, 4 and 5. So now this is our motor, our water pump, connected with a relay connected to the pins 8 and 9. And this is our LCD I2 12x6 I2C LCD connected to pin A node and A1. Now let's run the simulation. So after obtaining all of this, we can now run the simulation. So to run the simulation, you need to insert the coding. So to have the coding, first run the coding through Arduino, then press the coding, use the hex file and enter it here. After entering, press OK. Now let's run the simulation. So after running the simulation, you see a virtual terminal appears. From the virtual terminal, you can see the distance, the pH and the temperature. And the temperature, the thing will continue on. Okay, so as you can see, the distance, you can change the distance by moving the potentiometer. So as you see, when I move the potentiometer, the distance will also change. You can see the distance changes. Okay, the control moves together. So when the temperature, when the distance is more than 10 centimeters, the LED will light up. And when the pH is more than 50, the LED will light up. And when the temperature is more than 30, the LED will light up. Okay, that's all for me. Thank you.
Okay, hello everyone. My name is SELVAM. My ID number is EC21073. So I'll be showing the prototype right now. So firstly, we have the display here. As you can see, the display right now is showing the temperature and also the pH value. So to show that it works, we start off with the temperature first. So for the temperature, alright. So first, we put in the warm water. Alright. Okay. so the warm water right now. As you can see, the temperature increases. Okay, now we're trying for the cold water. Okay, and you can see the temperature decreases. Now next, for the pH value, this is the pH sensor. So for the pH sensor, we will put in the alkaline first. Alright. Okay, now as you can see, the pH sensor shows the reading, the value increases. Now I'm going to put it in the acidic substance. Okay, as you can see, the pH sensor is in the acidic substance, and you can see from the LCD it shows 7 in the value of pH lah. And the reading can get from the monitor. Alright, serial monitor. So now I'll be showing the water pump that regulates the water temperature. So the water pump is connected to the relay inside the box, and the relay is powered by the power bank over here. So how it works is the water pump will get an input from the temperature sensor. Right now, as you can see, we put the temperature sensor in the cold water container. See the temperature. Alright, so it shows 15 degrees Celsius. Now if we put the temperature sensor in warm water, okay, so while it's increasing, so we set the threshold to 34 degrees Celsius. We connected the water pump to the as you can see over here is the tube into the big water container. You can see this, I placed the temperature sensor in the warm water over here, and as you can see, the LCD shows high temperature 34. So we already set threshold. As you can see, the water start to pump out from the tube. That's how we regulate water. Okay, now we're gonna from the warm water, we're gonna put it in the cold water. Alright, so now as you can see, it stopped, and the temperature decreases, and as you can see, it stopped.
Assalamualaikum, and now let's move on with the conclusion. So the recommendations and the conclusion. So in the recommendation, the accuracy of the pH values can be improved if we use multiple pH sensors, and we should also try many more Wi-Fi modules as a backup. So this is done to increase the accuracy of the pH reading, so that the water pH level for the hydroponic system can be obtained fast and exactly as intended for the plant. So now in conclusion, the drawbacks and the future improvement. The drawbacks are that it is ineffective water cooling method, and the future improvement is that we would want to address water cooling method and inefficiency. Our hydroponic project has been a success with the exception of one project, but objective. We couldn't establish a Wi-Fi connection due to a faulty module. However, we displayed important data like temperature and pH on the 12x6i2c LCD and the serial monitor. We practically monitored water temperature and adjusted pH levels using pumps and liquid fertilizer. While there were limitations in the cooling water power supply of the pumps, we have made significant progress. So in conclusion, this project has been a very helpful medium for us to prepare for our project. And thank you, and that's all from us.